You got to keep it at 30 though.
Yes. Well, I always for the verticals. I keep that at 30, regardless.
Okay.
There we go. Okay. So we have a connection on.
Sorry, yeah. The standard the FPS for Twitch was 11, but it looked all right. There wasn't any lagging. There wasn't any stuttering.
But now you should be able to see us on YouTube. Yeah.
It's 1-to-1. There's no lag.
There's no lag at all. Yeah.
Maybe 3 seconds.
Oh, okay. Okay.
But it's normal. That's standard, isn't it?
Right.
It's never going to be immediate.
No, there's always gonna be some latency. What's up, Ethan?
Hello.
How's it going?
How's it going?
Good. We're just figuring out some figuring out some technical things.
This is why I'm not seeing the screen.
Yeah, it's not on Twitch. I don't know. Sensation's probably right. My OBS is just broken with Twitch, which is annoying.
Okay. So yeah, like what? Has it been like 2 weeks since I last chatted with you?
Yeah, it probably has been.
Okay.
Here, I'm gonna throw TikTok on and see what TikTok says.
Just a sec, Ethan. Just pull everything up and see where it starts to crap out.
Yeah. Well, yeah. I'm streaming to TikTok too now. Seems to be okay.
Twitch is off.
Yeah, I turned Twitch off.
Okay.
Yeah, TikTok is live. That's fine. That's showing me 2 kilobits up. This is showing me great. Yeah. This is fine. So just Twitch. Twitch just doesn't like me for some reason. Yeah. Cause here, watch. I think if I do this, here I'm gonna have it manually start setting it to. Yeah. Twitch, it says it's now sending at 4 MIPS. That's okay. 5. Is it live on Twitch? Curious.
Yep.
Okay. And does it look laggy?
I see it there.
I'll keep that central and I'll tell you if it does anything wrong.
Okay.
I'll tell you if it does anything wrong.
Maybe it's just like my built-in canvas just isn't working. I don't know. Seems to be fine now. Yeah, because now I'm seeing 5 MIPS up. Maybe the 30 FPS fixed it. I don't know.
It's smooth.
It's smooth. We love smooth.
Okay. Laramie cigarettes.
Let me make sure.
Is that a real brand or is that just for The Simpsons?
No, I think it's just for The Simpsons. Laramie cigarettes.
Yeah.
One sec. Let me turn this off. Okay. That seems to be working. Here we say test. And I'm going to activate this one. Bum, 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 bum.
Oh, it looks good.
Oh, it looks good. Okay. Maybe you're right. Because what I'm doing is I'm doing a third party stream. I'm doing the RTFP direct thing to Twitch. I think the 30 FPS probably helped too, honestly.
That's never been a problem for anyone I've ever met, so I don't think that's it.
Yeah. We'll figure it out. Wait,
isn't the one with just one button that says, so you say start multiple streams, and yeah, it's
yeah. So you have that.
For OBS. Yeah, no one's ever had any problems with that, as far as I'm aware. So.
Oh, okay. Here, I want to make this one visible real quick. Oh, that is okay. Here we go. Test. See if the YouTube works. Why is nothing displaying on my stream though? On my Twitch.
Test.
I'm seeing nothing on multi-stream though. What the hell? One sec. Let me kill this. One sec. Social stream. There we go.
Let's just conduct the entire stream in different languages. It's Misha Sensation Black.
I just want to see my Twitch chat. I'm just like, how is this much to ask for? Can I see my Twitch chat? Cool. Trigger fake message. There we go. Okay, now I can see that. Okay. And then does this work? If I say like, one sec, testing Twitch. Yeah.
The
Okay. Cool.
latency on Twitch is gone now.
Okay. All right. We figured it out. So I need to like just not hit. I have to hit another button to stream from Twitch. You're right. There is just something messed up with OBS at this point.
Are we back on track now?
Yeah, you can talk. What's up, Ethan?
Well, hey, I mean, I'm on Easter. I'm sorry if you hear a dog barking. That's just how it is right now. But
okay, that's okay.
Easter's been going great.
Nice. Easter. We love Easter. Easter's great. Yeah.
And it's only 1 week before I go back to school again.
Okay.
And so far my grades have actually significantly changed.
Nice. I hope for the better. Have they been changing for the better or the worse?
I mean, it looks like it's changing for the better.
Oh, nice. Love that, dude.
That's dope.
Do I want to see your grades? Yeah. Show me your grades.
Yeah. All right. It'll just take like a couple of seconds here.
Yeah, go find it.
Screenshot.
Send me a screen shizzle.
Who the hell is Steve?
Who the hell is Steve? Where's Steve? Where do you see Steve?
On the YouTube thing, it says Steve_2386 and so on.
Oh, okay. Who else?
Okay.
What's up, Steve?
What do I send it? Where do I send it?
Just DM it. You can DM it to me if you want.
I can send it in the chat. I can do that.
Yeah, you can do that too. There you go.
Could be in.
1 sec. I gotta like pull up my Discord. Bum 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 bum. Oh, I don't see it in this chat. Is it a different chat?
It's in the same office hours chat. What?
Oh, the office hours chat. No, put things in the stage chat when you do things.
Oh, didn't I put it in the stage chat?
No, I don't see any. I don't see any of it.
If I put it in the stage chat, it's right there.
Ooh, someone has a good question here about revolving stuff on an axis. Thank you. Who?
Who's here?
I can help with stats. Who's try me? Is this someone else's question? Is someone here? 1 sec. Someone else? No, that was right. 1 sec. There you go. That question.
Just quickly before we crack on, I can't see the chat on Twitch. Oh, there it is.
Yeah, I think it's working, right?
It wasn't in the other screen.
Yeah. Which, yeah, good question. I don't know why that's not showing. Oh, you mean on this one? Yeah, you're right. This one isn't showing now. What the hell? Yeah, what? Why is that not displaying?
Why is everything crapped out?
Why is everything broken today, dude? What? I don't know. Okay, whatever. It is displaying on the other. It's displaying on the mobile one, which is I don't know. Everything's broken today. And then yeah, Ethan, I don't see anything. You didn't send me anything. Maybe send it to Sensation. Let me try this one. I just want to do some math. Who's yeah? Send me some stats. You know where to send it. All right. Calculate the what's up, Reki? Calculate the volume of the solid generated by revolving the curve about the. I assume this is the x-axis. Is what we're saying. Okay. First thing to do. Oh wow, this is an axis.
Yep.
Sorry, this is a parametric equation. Yeah, Ethan, what's up? I don't see anything, dude.
I thought I'll just put it in the DMs then, I guess.
Yeah, just DM it to me.
Fine. All right, it should be in there for your DMs.
There we go. See that I can see, Ethan. Yeah, I see that, dude.
Oh, all right. Yep.
Nice. These are your grades so far. Ooh,
Yep,
look at that.
there.
92 in
So
CS. 92 in biodiversity. Nice. 92 in math. That's great, dude. Wow, physics 91. Oh, you have all A's. Well, except for 1B or 2 B's in English and literary interpretation. Nice, dude. All A's,
English
man.
and yep.
That's great, dude.
Don't worry. There's still time. There's still some grades to be imported. So
Yeah.
these will definitely change.
Okay.
No hablo inglés.
Kind of worried.
No hablo inglés.
Kind of worried. It will happen. There will be changes.
Yeah.
By next week, it should be done. It should be done.
Nice. Chantrix, all good. Is that the God of War I bought you? Did I buy you God of War? I bought somebody God of War. Someone said they were playing God of War. Yeah. Ragnarok, sick dude. Nice.
And YouTube chat's not working.
YouTube's not working? Really? Oh, are you the math guy? Oh, yes. I remember that watching you on Twitch like at the start of the year. Now I get recommended to see you on YouTube. Such a weird coincidence. Yeah, that's cool. Tariel is saying that. Yeah. Yeah, why was that not showing on this? Sorry, what? It should be showing. Yes, I am the math guy. Also the physics guy. All sorts of guys.
5 guys.
Yes, that's me. Dun, dun, dun. Okay. These are curves with respect to t. What? What the hell? X equals 2 over t squared plus 1. But what can t be? Is t from like negative infinity to infinity? Okay. One sec. Please hold. A lot of please hold today. A little bit of a rough start today.
Hello, I submitted my question to your Discord on statics. Please help in writing today.
Yes, you did. He did on Wednesday, I believe is what he did. Right? Wednesday he submitted the... Were those all these questions? Where were they? I think they were... Yeah, these ones. These are all your statics questions. I think these were them.
It is Monday, my dudes.
It is Monday, my dude. But yeah, he gave those to me, I think, on Wednesday.
No, I don't. No, I don't want. What? Sorry, this dude's writing in 2 different places. I'm having a hard time keeping up with it.
Sorry, where is he writing?
Common area. It just says, no,
Oh.
I don't.
Oh, he says yes on YouTube. I see him. He says yes. Dude, why is my social stream now not working, dude? What?
How was your work with discrete maths?
Not terribly great. I'm not super knowledgeable in discrete.
I don't even know what that is.
It's like kind of like proof-based stuff.
Okay. No, I'm terrible with proofs.
Yeah. It's like groups and sets and things.
I did read that kind of stuff in GCSE, but I never used it.
All right, let's see. That works. Okay, cool. Yeah, that one works. Cool. And then we just need... Yeah, there you go. There you go. Have that one work, please. Therial Colonel said yeah. But you can try a question. Okay. Okay.
Please submit a question. Please like the stream. Please subscribe, etc.
Yeah, all the fun stuff. Here, let's do this one. All right. If I'm revolving something about the x-axis, I'm going to try to figure out where this thing hits the x-axis. Okay. So for these curves. So when it hits the x-axis, that's when y is equal to 0. So. Because we got to get bounds on t, because this is parametric. So here, I have 0 is equal to t to the third minus 1 over t squared plus 1. And so that's going to occur when t is equal to 1 or t is equal to minus 1. But then let's check what happens if this is minus 1. That's not possible. Right? X can never be negative 1 because it's 2 over t squared plus 1. So the lowest this can be, x can be, is 2. Wait, sorry. When t equals 1 or t equals minus 1. So then let's just check what x would be. So if t... Oh, 1 and minus 1 are the same here for x, though. So here you have... Yeah, you're going to have 1, 0. And then this is also just going to be 1, 0. Okay. And then... Why do we start it at 0 as well? Okay.
Ooh, getting some hearts.
We love hearts. And at t... Don't even know if anything else comes new in the chat. I should be seeing it here, but okay. And at t equals 0... That's going to correspond to the points of 2, and then that's going to be negative 1, negative 1. Okay, cool. All right. Cool. So, volume integral around, if we're revolving around the x-axis, right? That means I'm going to need to do dx, and then it's going to be the integral from x0 to x1 of 2 pi, and then the radius here is going to be y of x dx, or 2 pi r squared, y of x squared dx. Okay. But there's some weirdness here because y does not depend on x, y depends on t. Okay. So let's try to relate these two, right? So if this is x of t, then dx is equal to 2. And then I want it in terms of dt. Let me see. 2. And then that's going to be... All right, let me rewrite this. This is the same thing. This is a difficult question, dude. Because it's in parametric form. This is the same thing as 2 times negative 1 times t squared plus 1 to the negative 2. And then it's going to be times 2t dt. Okay. Cool. So I got a 2 there. Okay. So this is the integral. And then for dt, let me think. We're going. So now we've changed our bounds from x to t. So now this is going to go from 0 to 1. And then y of x is now y of t squared. So this is going to be y of t squared dx dt. Well, here. And then dx is now equal to 2 times negative 1 t squared plus 1 to the negative 2 times 2 t dt. Okay. What a mess. Okay. So we can start pulling out things. Let's pull that out. Let's pull that out. Let's pull that out. So that's going to be 4/8. So that's negative 8 pi. Integral from 0 to 1. And now this is going to be t to the third minus 1 squared over t squared plus 1 squared. But then this is 1 over t squared plus 1 squared. And then we have another t and then dt. Okay. So it ends up becoming... Oh, and sorry, it's pi r squared, not 2 pi r squared. I was thinking about for shells. Sorry, this is 2. Yeah, okay. Now it's negative 4. And then is there another minus sign somewhere? No, I don't think so. Okay, so then it's negative 4 pi, integral from 0 to 1, and then this is t to the third minus 1 squared t over t squared plus 1 all to the fourth dt, which, wow, this is a mess. But, do you want to do partial fractions with this? I guess you could. You could do partial fractions on this because you have something to the fourth power, which means you would have repeated roots up to fourth. Man, this would really suck though. Oh, am I not streaming here? Let me stream here on Discord too, so you guys can see what's happening. Or actually, I'm not going to risk it. I don't want to risk my bandwidth.
Would you risk it for a biscuit?
Seriously. Okay. Turns out, I'm just going to plug this into Wolfram. Partial fractions. This is a mess. It's a god ugly mess. But,
actually, go on. Put it on Discord. I'll keep an eye on this.
Okay, you'll keep an eye on it. All right, one sec.
I think it'll be all right though.
All right, let's try it. One sec. Let me put it on Discord.
Who's so wrong?
All right, one sec. Here you go.
I don't know why I asked you.
Okay, there you go. It's still streaming.
Well,
yes, and after that part,
slightly.
It janked out slightly. Okay, yeah. Okay, after that partial fractions, this is eventually just going to get you. I'm just straight taking Wolfram from this. They say negative 7 over 12 minus pi over 8 plus the ln of 4. Yeah. Okay. For this part. Actually, but oh, that was with the 4 in it. So actually, sorry, it was really like this. This was inside. So then you just have the pi. And so you should get pi ln of 4 minus 7 pi over 12 minus pi squared over 8. This is a really ugly question, dude. What? Like, what? Why? What level of math are you having to do? I don't know. Volumes of revolution is one thing, but then to do volumes of revolution in parametric, I was like, why? Like a vector calc question, I guess, or something. But yeah, this was the question. Academy of Uselessness. Academy of Useless Ideas. It was, they gave us parametric form of a curve. This seems to be a Calc 3 problem. I remember doing this a lot. Yeah. So, I mean, yeah. Right. Yeah. What would you like me to help with? To help with Ayustin?
It's all smooth. Don't worry.
Okay. I'm trusting it. Okay. Let's see. Oh, the convergence. Oh, that's a fun one. Okay.
Ziphon. I can't even say that. Ziphos.
Ziphonk.
Okay. once
Yeah,
in.
thanks. Yeah, it looks hard. It seems like it could be slightly easier in polar coordinates, but I'm not sure. Yeah, I'm tempted with the t squared plus 1, but then t cubed minus 1. That's like, no.
No.
T squared plus 1 maybe, but the t cubed minus 1, yeah. So yeah, general strat is you have to find your bounds on t, which requires a little bit of like clever intuition. And I mean, I think in this case it's just finding, well, where do we hit the x-axis? We hit the x-axis when y equals 0, and that occurs at t equals 1. Oh, that only occurs at t equals 1. It doesn't happen at -1. That's actually wrong, because t cubed keeps the negative. Yeah, so it only happens at t equals 1. And so then the other obvious place it would happen, well, the other part you check is from t equals 0, which is then this point.
Did you get that where he says, I'm not sure you used the right formula?
Oh, which formula do you think I didn't use right? You don't think I like this one? This one's not right? This is a general volume of revolution, right? It's pi times, and then it's your bounds, right? x1, or I used x0 to x1. And then it's r squared dx. This is the general form for the volume of revolutions. The difference is that now x is parametric. So we need this as a function of t. So now this is going to be from t equals 0 to t equals 1. And then dx needs to be written in terms of t. And then r here is going to be y of t. That's the parameterization of it. And yeah, so that only... Yeah. Oh, the formula of volume about the OX axis. Oh, okay. So maybe this is something new to me, Desmal. Sorry, I've never seen the OX axis. I thought this was a typo. I thought it was just around the X axis. What is the OX axis?
And why have you spelt Jamal with a D and Z? Are you check?
Okay, here, this is what they're saying. So OX axis and O8 means the positive axis of the image coordinate system. What? Oh, wow. Yeah, I don't think I've seen this. I guess... Oh, that's probably why we're only saying the positive x-axis. Oh, it's Bosnian?
Ah, that makes sense.
Oh, well, yeah. Okay.
Zifozny. I can't even say that. Sorry. He just asked in a voice message, is this calculus 1, 2, or 3?
This is calc 3. Yeah, this is calc 3. I would say it's calc 3. Oh, OX is just the x-axis. Okay. Well, yeah, then that makes sense to me. Right, yeah, cool. Yeah, sensation. The cam was working at least. Okay, cool. Zimfonk, where'd you post yours? And then I saw Stanley Dumford posted this one. I wish people would use the same name that they use on TikTok and stuff.
Be consistent, twats.
Yeah, it's hard for me to like recognize who's who, man. Okay. Okay, what's up, Sarong? All right, let me see. Dennis had this question. Oh, that's a very interesting one. Where was the one Zimfonk posted?
Zimfonk keeps trying to post voice messages, but they're all just blank.
Okay. All right, here, let me do a Darsha's real quick because he has been waiting for a while, and then we'll come around. This one's pretty easy. This is probability. Good old probability. One sec. I need this to... One sec. I
can't quite make that out. He posted something on Wednesday, he says.
Yes, yeah. Oh, he posted a bunch of them. Which one did he need help with? Dude.
Just type, my dude, please.
Yeah, okay. Here, Adarsh, let's do you real quick. In a deck of playing cards, what is the probability of drawing a red card given that it is a heart? Okay, cool. This is it. This is called conditional probability. So we say the probability of A given B, which I want to say is the probability of B given A times the probability of A all over the probability of B. I think this is how this works. I might have it wrong. I'm just doing this off the top of my head. So let's see. Conditional probability. Oh, it's a probability of A and B over the probability of B, which I think is probability of B given A. Yeah, this is what I was thinking. Yeah, it's Bayes' theorem. Bayes' theorem. Probability of B given A times probability of A over probability of B. Yeah, I think that's what I had, right? Okay. So, this is red, given that it's a heart. Oh, this is just 1. Yeah, it is. Because all hearts are red. Okay.
Except mine. Mine is just black.
Mine is black. Okay, so this is the same thing as like, what's the probability of a heart given that it's red times the probability of it being red over the probability of it being a heart. Does this kind of work? I'm just kind of curious because you don't get 1 here, right? Probability that of it being a heart that given that it's red, that's 1/2. And then the probability of it being red is 1/2. Oh, and then the probability of it being a heart is 1/4. Oh wow, this is pretty cool. You get 1/4 over 1/4, which is also equal to 1. Yeah. That's actually kind of cool. So Bayes' theorem actually does hold up here. But yeah, you should really know this, you know. If it's a heart, it has to be red. So the probability of it being red is, yeah, that's 100%. Oh, it's okay. I mean, still a good question. This is the equation you want to learn, though. It's called Bayes' theorem. It's important. Still get points for that. Okay. I want to see. So, Zimfunk, pick out of your questions you submitted here. Pick a number, but don't choose 5 because we already did 5 last time. But pick any of the other ones, and I'll try to do one of them. Oh, you noticed to submit a screenshot, but I don't need help. Oh, that's okay. But I want to ask to keep you as a source for help. Do you work with converting prenex? Prenex to what? What's the other part of that sentence? Oh, and Skolem rules. I have no clue what those words mean. So no. But if it sounds like kind of like some high level math you're doing, which we do have. I mainly work with high school and like early college, but we do have some other streamers here on Twitch that have like PhDs in math, and they do like really high level math. So like really high, like discrete and all sorts of fun stuff. You should definitely follow them. Here's like a little math. The math streamers is where they are. But yeah, can I copy that into YouTube somehow? There you go.
Before you continue, how did you get to 56?
What was 56? Sorry.
Well, Scott says 1 out of 56. There's 52 playing cards in the deck.
Oh. Yeah, I don't know how we got 1 out of 56. The answer is just 1. Yeah, I mean maybe there's 56.
He's counting the jokers.
He counts the jokers. He's counting the jokers, dude.
There are 4 jokers in a non-standard deck, isn't there?
Yeah, there are 4 jokers. Okay, let's see this. This is a convergence question. I like convergence. Estimate the convergence. Examine the convergence of the series depending on the real parameter A, where n is a natural number. Okay. This to me. Oh wow. It's tough out here. I feel like I'm balding anytime I think about math. No, you're all good. Here, I'm gonna give you the Twitch of some really good friends of ours that do really high level math. Let me I'm trying to copy paste this for you. Because you're not in Twitch. You're in YouTube. But, that's e to the 2i pi. He's a very, very smart math guy who can probably... You should check out his Twitch. And he streams pretty regularly. And then there's Penn Center, who teaches math actually at a university. So he's another good guy. Okay. The convergence of this to me like feels like I should use the root test. And Zimfong says, I choose 5 and 7 because we couldn't get the answers to 5. That's correct. Yeah. You were talking about, yeah, this one. Yeah, we did this one like twice over, and I think this is wrong. But okay, good to know. 7. You want to do 7 next? I'll do 7. Yeah, cool. Like that. That should not be too bad. That's just components. Let me put that over here. Okay. Examine the convergence. Okay, I feel like I want to use a root test here. Because anytime I see like... Well, it's weird. It's like to the power of the root. Also, like, what does this mean? What is this? What does this thing mean? Is that a bracket that just got cut off? Also, wait, n has to be a natural number. What happens if you have like -1 to a decimal? Right? If I have -1 to the square root of 2, what is that? We know, right, for instance, that -1 to the 1 is equal to -1, and -1 to the 2 is equal to 1. Oh, it's a floor function? Oh, okay, cool. Yeah, I was like, I've never done -1 to you know, an irrational number. Like, what? Okay. Well, I would say by the alternating series test, because I assume this is going to alternate, right? So I would say by alternating series, all you have to prove is that this thing is declining, which it always is. So long as like A is not negative, right? A was negative, then you could have something that breaks. I think this converges for all A is greater than 0. Yeah. Or A is greater than -1, right? Because n starts at 1. Ever have the Oppenheimer sound play subconsciously in the back of your head? Is that it's the confusing one? I'm trying to think, which one was that? Is it this one? No, it's not that one. One sec, I'll find it. No, it's not Mr. Bean. It's not Drake. Not that guy. One sec. No, come on.
Kurt Angle. Is that Kurt Angle?
I think it's Kurt Angle. No, not the Joker. No, not Keanu. This thing is on a random thing. It'll eventually get it. No, that's the Cats. No, that's that. Oh, one sec. That's Borat. No. There we go. This is the one. This is it. Is this what you're talking about? I think that's the one he's talking about. Is that the Oppenheimer sound? Anyways, yeah, I feel like this converges for everything. Let me just... I'm gonna put this into good old ChatGPT and see what they say. Like to... And they released a new one. They released 04. It's like the super heavy ChatGPT. So depending on your dominant denominator, it's either above or below 1.
Right, I've decided.
What you decided?
I'm going to take over the worldwide educational system, and all children must learn a history of video games.
Oh, I think it's a good one.
They've all got to start at like NES or something.
Oh, this is interesting. Oh, okay, cool. Kind of like this. So, yeah.
So, alternating series test doesn't apply here.
It doesn't? Because of this thing,
Yeah.
This thing is not alternating
Because
back and
it's-
forth because of the floor
it's minus
stuff.
1 to the floor of root n.
Which is ugly, dude. What? Right? Okay. How would you... Dude, I'm seeing some, like, really, really ugly thing for doing it.
So I'm thinking we group the terms by the ones that alternate, and then analyze it that way.
Uh-huh. This says, like... It says there's conditional convergence by block alternation. Which...
Yeah, block alternation is, well, based on the name, I'm guessing it's you take a look at the first few positive terms,
Uh-huh.
and then you stop when there's a negative term, and then you group that together. And then you look at the first few negative terms
This is
after
all...
that, and then
I've
you group
never...
that together.
What level of
And
math
then
is
you-
this? I've never seen this in like a high
I
school
feel
or
like
even
I
college.
didn't take the class with series in it because I learned series independently, but so I don't know what level of math this is, but like
This to me doesn't feel like high school. This is
something
definitely
I
not on
figured out by
AP.
myself without reading a textbook. So
Well, props to
like
you, P127 for
after
like
learning the
that.
series tests,
Mm-hmm.
because it's the limit of the partial sums, right?
Sure.
So
Yeah.
you can. So if you only look at the partial sums where it stops right before it changes sign.
I
that's
see.
like- right?
Yeah.
And you can show it's an if, and you can show it's an if the other way. So it's an if and only if.
I see. Right. So they say square root of n is equal to k exactly for n is
Yeah.
here, because this is like the floor of it, I guess, right?
So you block it.
Uh-huh. So that's the length of it on which the sign...
And now
Is-
you're summing the blocks in order.
If we group these blocks... Oh, I see.
And summing the blocks looks kind of ugly.
This looks really ugly.
Oh.
Dude. That's why I say this is not a high school. This is not a high school question. I wouldn't even say this is a college
You can
calculus.
estimate it.
Yeah.
No, this feels like something I could do. I'm not in college yet.
Yeah.
This feels like something
You're
I
not
could
even in
do.
college? You're not even in college, P127? Really?
16.
Oh my god. You're a fucking genius, dude, at this age. What? Like, good job.
Everyone's saying that, and I'm not sure if I believe them.
I believe it, dude. I'm gonna tell you right now, dude. I have a PhD in physics. You're a fucking genius.
Yeah.
I agree, but then at the age 16, I was a window licker, so yeah.
He was a window licker. Yeah, dude. Any of this, dude, like what? Dude, none of this stuff is ever covered.
It doesn't feel very hard compared to
I'm glad
category theory.
Category theory? Yeah, see, like, but most kids, like, yeah, no, it's not even happening. Again, but yeah, I am proud of you, P127.
Yeah, basically you block them and you can analyze the asymptotic behavior that way.
Okay.
And
Dexter. So, I think the final answer is that it's conditionally convergent.
it
think
feels
is what
like
we're
it's slightly slower than a harmonic series, so I think it might still diverge.
They say for large n, yeah, this does look like 1 over n, right?
Yeah, okay.
And so, right, because this is the same thing as 1 over the square root of n
Well,
squared plus
obviously it
na.
doesn't converge absolutely, but does it converge
Yeah.
conditionally?
Right,
Is
yeah.
the question.
They say yes. They say it is conditionally convergent.
I say yes.
Yeah.
So
Because they
they're small enough.
they group it here and then they say this, for instance, 2 of ln 1 plus 1 over k. This is monotonically decreasing.
Good comparison.
And then something of order
can
k to the
believe
minus
that.
2 is also decreasing.
Yeah, I can believe that.
Sure, yeah, I can believe it. I would never come up with this, but God bless the GPT gods.
I might come up with this if I thought about it really hard for a while.
Man, here's a, what is it? Demel submitted this here. I'll let you chew on this while I help out Zimfonk with his engineering question. But here, let me post it in the chat here.
Finite-dimensional vector space over the rails.
Prove that the kernel.
Prove that the kernel of L minus I. What's I? Identity.
Probably the identity one, yeah. Is, I guess, contained in the imaginary of L minus I.
L minus I plus M of L minus I.
Yeah, what's up, Obi? Obi's another big math guy.
Is this not just true for any linear operator? Hold on. Isn't this like the second isomorphism theorem or something?
Yeah, see, you guys are talking about things I don't know about.
No, the first isomorphism theorem.
Desmond says he can provide proof.
Be something like the
stuck.
first isomorphism theorem for linear for vector spaces or something.
Yeah. All right, I'll let y'all chew on that. I'm gonna help out Zimfonk with his question here, which I feel like is probably a little bit more doable. Which is, curriculum tonight, working on functional analysis, pre-calc 1. Okay, pre-calc 1 I like. It's interesting they call it functional analysis. It's like, what, just analysis of how functions work? Obtain the components of F equals 15I, 25J, K, newtons, parallel and normal to the plane ABC. Okay. So this is a plane. Normal to the plane. I need the equation of the plane, which I believe I get the equation of the plane from like cross-producting two of the vectors, basically. I believe that's what we do. Like if I just take like, what is it? Whatever this cross this, that'll get me the normal vector. And then I think I just, I dot this with this. Properties and manipulation is my term, not my old school. Okay. Dun, dun, dun. Let's see. Wow. Thank you, Sensation. I do need to hydrate. Actually, I even have some nicer like pink lemonade here. Okay. So let's get the points for this. This right here, in X is 2, and then in, I assume this is Y. I assume this is, well, actually that's actually, is this Z? I kind of cut it off, didn't I? Sorry, my bad. Yes, good. It is Y and then Z. Okay, cool. So that's 2, 0, 0. This is going to be 0, 6, 0. Is this Z? Yeah, the meme, dude. Is this a Z? And then the other point is 0, 5. Okay. Okay, So let's get vectors for things. Let me get, for instance, AB, which would be equal to, so that's going to be 0 minus 2, 0 minus 0, 5 minus 0. Okay. And then let's get another vector here. Let's get AC. Because then if I have two vectors in the plane and I take the cross product of them, that'll get me the normal vector to the plane. And then we can use that to figure out the equation of the plane, right? So this is going to be 0 minus 2, 6 minus 0, 0 minus 0. Okay. So final form for this one is -2, 0, comma 5. And then, sorry, that was AB. And then AC is going to be equal to -2, comma 6, comma 0. Okay. Now let's cross them together. So now I'm going to do AB cross with AC to get the normal vector to it. What's up, Ziad? Okay. So, alright. Let's do this. So, I, J, K. -2, 0, 5. -2, 6, 0. So that's going to be -30I. Plus 10J. And then it's minus 12Z, I think. Or K. Yeah. I think so, right? -2. Did we do that correct? And 2, 0, 0. 6, 0. GCSE math tutor. Yes, correct? Okay, cool. All right, nice. Okay.
Interesting to see I'm not the only lunatic from that side of the world of still awake.
You're not. You're not. Fun fact, I extend the matrix to the sides. Yeah, you can do that. You can do this thing, and then like you do like all this, and I think this works as well. W man's for helping helping people out, man. Making America smart again. Massa. Should we start making hats? Massa. Make America smart again.
That's rather unfortunate. Think about that again.
Yes, I know. I know. No, Massa. Can't actually be saying that.
I'll be a good boy.
I swear. Okay. So, all right. Okay. All right. So that's the thing that's normal to it. And then I think we dot product that with just F, I think is what we do.
Reminds me of that stupid meme. 4 years for your bachelor's, I worked 50 years for my master's.
Oh my god. That's fucking awful. One sec. Zero, comma, 0, comma. I just want to double check this is right. Okay. Boom, 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 boom. Okay, so this is n. This is normal to the plane. So, I believe I just dot product this with this to get the components. Or wait a minute. AB was that cool? Oh, this is positive 30. Sorry, yep, this is right. Sorry, positive 30. What you do is you block this, and it's no, that should be negative 30. No. Yeah, it should be negative 30. I'm not crazy. Negative 30, and then it should be... It would be positive 10, but then it's negative 10. Sorry, this is negative 10. And then... That would be negative 12. Yeah.
Actually, there's a question, just not on this. Is GCSE Maths Tutor still here? Just out of curiosity. I'll wait for him to answer later.
Let me make sure I have that right, sir.
I owe him a debt of gratitude, actually.
Right, and this should be negative 30. Sorry. Yeah. Oh, okay. But we can also take the vector in the other direction. Even though these are all negative, you could change it in the opposite direction. And so n could also be equal to just 30i plus 10j plus 12k. Okay, good. All right, so then what we need is we need n hat, which is equal to n divided by the magnitude of n. So that's going to be so here, the magnitude of n is equal to the square root of 30 squared plus 10 squared plus 12 squared, which, what is that? That is a ugly, ugly number. Where's my calculator? Okay. So, square root of 30 squared plus 100 plus 12 squared. 33.83. So that's going to be 30 over 33.83, comma 10 over 33.83, comma 12 over 33.83. I see. Okay, cool. Okay. So then to find the parallel component, oh, kind of cool. Okay, I kind of like this. This is very cool, actually. Yeah, okay, so F perp is going to equal to F dotted with n hat, and then we're going to multiply that in the n hat direction, okay? So you have to do the dot product first. This gets the component of F in the direction of n, and then we're going to multiply it by the vector n hat. And this is a unit vector, so it's not going to affect the magnitude. I see. Okay. So, wow, that's kind of mean. And what was it? 15, 25, 55? So, F was equal to 15, 25, 55. Okay. So, you're going to have 15 times 30 over 33.83. plus 25 times 10 over 33.83 plus 55 times 10 over 33.83. That's what all this part is. And then we're going to dot it. We're not dot it, sorry. We're going to put it in the direction. So we're not dotting with this. We're putting it in the direction of n hat. What a mess of numbers this is, but okay. Here, let's store that as x. So let's just do 15 times 30 equals that. Cool. Divided by x. And then multiplied by 30 over x. And so that's going to get us 11.8. Which, they get 35.6. All right, let's see. One sec. What are we doing right now?
You didn't add in the other contributions.
What other contributions did I
You
add
have to add in the 25 times 10 over 33.83 times 30.
Oh my god, you're so right, P127. Thank you. Yeah, okay. Sorry. I was getting confused with my dot, but this is not a dot product. This is not a dot product. This is vector. This is scalar. Thank you. I was looking at that, I'm like, that's not right. Okay. 15 times 30 equals that, divided by x, plus 25 times 10, all over x, plus 55 times 10, all over x. And that gets us this number. I like this number. Okay. 36.9. This is why I hate engineering, honestly, because what does this really teach you? It just teaches you to hate doing like calculations by hand. Oh man. Okay, so now I'm going to take that number, I'm going to multiply it by 30 over x. And that gets me 32. Well, okay. Now we're not getting the right number. God damn it. Mm-hmm. 15. Yeah, 33.83. Okay, cool. The engineers write I for imaginary is J. Yeah, they do. It's weird. Sorry. 15 times 30 divided by x plus 25 times 10. Do I have that right? Yeah. Over x. Plus 55 times 12. Oh. Okay. Yeah, that's right. I forgot. This comes down here. Divided by x. Okay, 40.2. Thank you. Okay, so now I do this times each one of these components. So I do that times 30 over x. Yes, now we have our 35.64. That's what we wanted, right? 35.66, whatever. Yes, okay.
Nice.
There we go. Okay, that's correct. Does that make sense, Symphonic, how we're doing that? Oh.
New follower.
Love the new followers. Thank you.
Hello there.
Hello there. Okay. 35.66. And then we'll do this. Sorry, this times this. So we got 40.2. Here, I'm gonna store this value as y. Store this y. Okay, so now I have 10 over x times y. And that gets me 11.89. which is
I guess
what we wanted. What's up?
TikTok.
I hit it again. Yeah, it went down. I think it should be good again. Is it okay now? 12x and then times y.
Just thinking about it. There we go. Yep.
Good. Okay. Good. And then this is equal to 14.26. Yeah. Nice. Okay. Which, yeah, that's what they had. Nice. Okay, cool. So that's a normal component. So this is equal to f perp. Now here's a cool thing. Is that f perp plus f parallel has to equal f total, right? If I have something, let's say for instance this is f perp, and then this is f parallel. Adding them together has to get me f. One sec, let me make sure this is working again. Okay, good. There we go. Okay. And so we have f perp, we have f. So that means that f parallel is equal to f minus f perp. So that's going to equal to 15 minus 35.66, comma 25 minus 11.89, comma 55 minus 14.26. Let's see if those are right. So 15 minus 35.66. That's negative 20.6. Let's see, is that what we had? Yeah, negative 20.66. Good, okay. And then we have 25 minus 11.89. That's going to equal to 13.11. And then 55 minus 14.26. And that's going to equal to 40.74. And this should be f parallel. And let's see, I think that was right. Yeah, nice, 40.7. Cool. Yeah, all right, that works. Just to recap what we did, because I know there's a lot of just brutal math just happening. Anytime you're given a plane, thanks SMG. Anytime you're given a plane, what you want to do is you want to find two vectors that are coplanar, like that are in the plane. In this case, we have 3 points, right? We're given a point A, we're given a point B, and we're given a point C. So I know A to C has to be in the plane, and I know A to B has to be in the plane. And so you can figure out what these points are, and that's what we did here, 005, 060, 200, to get two vectors, AB and AC, which span the plane. Two vectors define a plane. And from that, you can then cross product AB and AC. And again, to find the vectors for these, you just do like the second point minus the first point to get these. Now you cross product these, and that will give you a vector that is perpendicular to both of these, which means it is perpendicular to the plane. And that's what n is equal to, okay? Originally, we got n with a bunch of negatives, but you can always multiply a vector by -1 to just get it in the opposite like direction. So instead of it like pointing out this way, it's pointing down this way or something. That's okay. Once you have that, you then need to find the unit vector form of that. So that's a vector that has a length of 1, a magnitude of 1, that points in this direction that's normal to the plane. And so that's what we figured out here. Okay? Now, in order to find the component of f that is perpendicular to the plane, you want to figure out how much of f is in line with the normal vector, which is n hat here. So when you do f dot n hat, that will give you the amount of f that is in the direction of n, which is normal to your plane. However, this is not a vector, right? This is just the amount of it. And then we are going to multiply it by the vector n hat, so that now it turns into its own vector, which, again, has a magnitude equal to the dot product of f with the normal vector, but it's in the direction of the normal vector. And that's how you get f perp. And then we finally use kind of almost like a Pythagorean identity here, where whatever f is, it can only have two distinct components, right? It can have a perpendicular component of itself and a parallel component of itself. And the sum of those two components always equals the original vector. So if you know f, which we were given, we just figured out f perp, you can then figure out f parallel as being f minus f perp. And that's how you find, I don't know if there's another way to find f parallel, but that to me does seem like the most intuitive way to do it. So yeah, I hope that helped, Zimfonk. Did that help you out? If Zimfonk is still watching. Yay, statics. Yeah, Femvox. We were getting kind of wrecked on that statics earlier. But okay, cool. All right.
Okay, for all the people watching on YouTube, could you please hit that like button? Because I can see all 16 of you just sitting there not pressing that like button. I can't have that.
Sensations. He's the like taskmaster. Yeah.
I'll what's the word?
The beatings will continue until the likes happen or something.
Oh no, I was gonna be sort of nice about it. What's the word? Corruption. You know, where you give somebody something for.
Oh, a bribe.
I forgot what the English word is. Bribe. Yeah. I'll come to your house and bribe you with lemonade or something.
Oh, lemonade. Oh, yeah. I'd like some lemonade. I got some pink lemonade right now. Some Spindrift pink lemonade. Thank you.
Spindrift.
Spindrift.
Sponsored by Spindrift.
Sponsored by Spindrift. Well, it has like real juices in it. So I don't know. Like I used to love La Croix, but like it always reminded me of the taste of someone like coughing the flavor in the room next door. You're just like, okay, I think it kind of tastes like lemon, but it has a faint.
What's that thing? Hint of lemon. Deconstruction of broccoli.
It has a faint amount of lemon.
When will it stop? The imagination of the flavor.
Taste the rainbow. What was it? Eat the rainbow, taste the rainbow. What was that? The Skittles commercials. Do you remember those?
Taste the rainbow.
But wasn't like eat the rainbow? No.
I don't remember that. I don't remember that many. Go on.
No, I was gonna say, do you know what a rainbow bridge means?
Rainbow Bridge.
Yeah.
The Einstein-Rosen bridge.
No. I had to learn this today. Where's it? Wiki rainbow.
Oh, we a dictatorship here in the YouTube. Yes.
Yes.
YouTube Heil.
YouTube Heil. So, the Rainbow Bridge is apparently a meadow where animals wait for their humans to join them, and the bridge that takes them all to heaven together. I didn't know this until today. So if someone says disturbing. Like, it is disturbing, right? Well, I think it's in the context of like if you're gonna lose your pet, you say like, oh, they're going on the Rainbow Bridge. And I was like, oh, is this like a new like Mario level or something? And it's like, oh no, it means the pet is not gonna be with us anymore. So taste the rainbow. Hopefully, like don't taste the rainbow too much, man. Okay, let me see. Here was another question someone asked. It said in the graph below, how does the rate of change of y with respect to x behave? Oh, behave rate. That's cool. Rate of change of y with respect to x, that's the same thing as dy dx. Okay. Which is the same thing as the slope of a y versus x graph. That's what rate of change is. I think they call this like ROC sometimes. Yes, and Dennis, I'm going to do yours next. So, rate of change here is always seen as, so the slope is like the instantaneous slope. This is what the derivative is. So here, let's do it in rainbow order. Let's do it in rainbow order for the rainbows we're talking about today. So I'm just going to show in like rainbow order how the slope is changing as we move further and further along. What comes next in a rainbow? Roy G. Green, right? Yeah, green.
Red, yellow, pink, green, orange, and purple, and blue. I could sing a rainbow. Sing a rainbow too.
Did you ever know?
What, the TV show Rainbow?
No. For resistors, there's a mnemonic for knowing for resistors what the color bands are. Did you know about this?
I thought they were different depending on which country you're in.
Like these. You ever seen these before?
Oh, maybe. I think I've seen it in one of these books behind me.
Yeah. Okay. So here we go. So this is. So if you're ever in electrical engineering and whatnot, and you have to read a resistor, they're usually color bands, and then the bands tell you like what the different digits basically of things are. So here, so apparently this is bad beer rots our young guts, but vodka goes well. Get some now. Like what? Bad beer rots our young guts, but vodka goes well. Was this written in the Soviet Union, dude? What?
It certainly works well if you're an electrical engineer.
Yeah. There's actually some terrible ones. Sorry, how do you say mnemonic again? Mnemonic?
MN.
Oh, MN, that's what it is.
Mnemonic.
Mnemonic.
Mnemonic. As in Johnny Mnemonic.
Oh, here we go. Here's another one. BB Roy of Great Britain has a very good wife.
BB Roy of Great Britain has a very good wife.
Yeah, that's another one.
So is it an international convention? Are they all exactly the same?
Yeah, they're all the same. Yeah. The resistor color code is always the same, but
I could have sworn they were different at some point.
Yeah, this was the terrible one. I remember this one. It was like, bad boys ravage our young girls, but Violet gives willingly. I remember this one being displayed at some point. Yeah, it's terrible. But it was like printed out in my lab at some point. Like someone had just like, and I was like, oh my god, this needs to not be here. It's like a relic from like the 80s or something.
The fact that you can't even say that on...
I can't even say it on Twitch. Yeah, I had to like...
It's ridiculous.
Yeah, but it's... Yeah, I don't know. So I understand when some people... You have to what?
You have to talk about the bad things, or else the bad things have a tendency to repeat themselves.
Oh, that's true. That's true. Yeah, that's like the dog whistling thing. Yeah, but I will say, like, when people talk about maybe, you know, certain degree fields not being like friendly to women, I'm like, I get it, because yeah, some of them do have kind of like a bro culture around them of things.
Yeah, but whoever says that is a moron.
I agree.
Shall I explain why?
Yeah, explain.
Men and women, get this. Men and women are fundamentally different. We literally have different brain types.
I agree.
And so women tend to pick things which are more people-centric, and men tend to pick things which are more machine-centric. I don't know why that is, but it is 99.9 recurrent.
Oh, are you talking about the fields? Yeah, no, I'm just talking about the culture within it. I understand how like certain groups of people would not feel comfortable in certain cultures of things. It's probably also like kind of like this is a big thing in LA now. Is in our fire department. So the LA fire department, I think, is like 95% men, and that kind of makes sense. It makes sense for obvious reasons, right? Men are stronger, blah blah. You want a strong person, blah blah blah, to fight fires and stuff. I get it, but within that, I'm sure there are women who qualify to be as strong as some of the men there. Like there's some pretty jacked women at my gym.
No,
like they do exist.
No,
they do.
No,
but because it is predominantly men, it like the bro jokes, the locker room talk, like that type of stuff is like ingrained and pervasive in that job. So even if you were like a super jacked woman who could like lift more than like most dudes, just from coming into the culture, you'd be like, okay, but now I don't feel like all right, because like they're making rape jokes and stuff. I don't know.
Again, that kind of thoughts, that kind of thinking isn't particularly helpful either. I mean, yeah. I have seen a very jacked female lieutenant.
Yeah.
They exist. A 15-year-old kid just wiped the floor with her.
Oh, really?
So
I don't know. I feel like there's some girls at the gym that could wipe. They could wipe me. There's some girls at the gym could like just like they could take me out. They could benchmark me.
These tiny skinny boys just kicking the fuck out of a well benched lieutenant.
I don't know. right, anyways, let's go back to the rainbows that we were talking about here. Okay, so the slope here goes from being very steep, right, to like not so steep. Not so steep. Time constant tau. And then like to basically like flat. Okay. So the rate of change is decreasing and then becomes 0. Yeah, exactly. It's probably, yeah, it's flat here, right? Yeah, so the answer here is 3. Yeah. Nice. That was an easy one. All right, Dennis, let's do yours. And then I'm probably going to take a break and go to the gym and see if I can outlift some of the jacked women there. Sensation, in your day, dude, what was the most you could bench? Did you ever do like a bench?
To be honest,
like,
I'm just trying to think. Sorry, every time we have these conversations, I have to think of the American counterpart to all these conversations. Right, so I did ROTC.
Okay.
And then I got stuck in a bunker. Like, there was no need for me to be physically strong.
Oh, I thought we were talking about your SAS days that you don't talk about.
I was never in the SAS. I was never a spy. I was never in the SAS.
No. We don't take.
I was never a part of that unnamed unit that we don't have a name for.
Yeah, there we go. Dennis says, "Is there a way I can show you how far I can go and where I'm stuck at?" Totally, man. Yeah. Do you want to submit a screenshot of what you got so far? You can do that. We can totally do that. Problems 1 to 3 are to be solved by the method of infinite series. That means you must obtain a solution of that form. You must solve a sub n such that the sum gives the differential equation. Wow. Oh, we're doing differential equation derivatives? No, sorry, differential equation series. Yeah, derivatives of series. Ooh. Ooh. Yeah, what's going on here? Okay. So I'm assuming that like y is equal to sum a sub n x to the n. There's a rule for these. I need to remember what it is. Derivative of series formula. It's like you drop the indice, I think is what it is. Yeah, here we go. This is what it is. But then there's something with like the integral. No. Where is it? I remember one is, it's like you bump up derivative and man, I could have sworn the index changes. Or maybe it's this. One sec.
Well, while you're reading that, and I've got a captive audience,
What's
I
that?
will remind everybody, save a dog today.
Save a dog.
Doesn't matter
today.
from where, doesn't matter whom, just save a dog
go find
today.
a dog. Go save a dog like an animal?
Aye.
How can someone go save a dog? Sensation, tell us.
And there's always so many dogs just kicking around. I mean, just,
Just take it in.
feed the poor dogs. I mean, people get dogs and they abandon them, and it's fucking horrifying. It
is horrifying. We don't see that as much here in LA because I think we have like a pretty good like kennel system, but I've definitely heard about that in like Mexico and stuff. Like they're just not rabid, but wild dogs just like running around everywhere.
We have a fairly international audience as well, so I mean, not every country deals with it in the same way.
I see. Man, I could have sworn there was something. Oh, he has something for me. Let me see what Dennis posted. Yeah, that's what I thought it was. Yeah, the index goes up by 1, right? Yeah, because the 0th one isn't a derivative. Yeah. Okay, cool. Yeah, I agree with this. Yeah. Yeah, okay. Right. Yeah, if this is... Yes, no, I agree with this. And the reason for this is actually pretty cool. So if you have... y is equal to the sum from n equals 0 to infinity of a sub n x to the n. This is the same thing as a0 x to the 0 plus a1 x to the 1 plus a2 x to the 2. Now, if you take the derivative of this, right, dy dx, you have to take the derivative of all these terms. X to the 0 is just 1. So you're taking the derivative of a constant. So now this is equal to 0. Then this ends up becoming a1 times 1. And then it's x to the 1 minus 1, so it's x to the 0. And then this becomes a2 times 2 times x to the 1. So you start seeing a pattern here. We're like, oh, this is now n equals 1 to infinity, a sub n, x to the n, and then it's n, x to the n minus 1. Because this is like, right, a sub n, n, and then this is x to the whatever this was minus 1. And it kind of looks like it, right? You bring this down, you drop this by a power of 1, but then you need to increase this index by 1 because the constant term doesn't just goes away. Okay. Cool. Okay, I agree with this. This is good so far. And then this is good so far as well. Yeah, you just drop it again, you pull out another factor, and then you increase the index. Great, awesome. So you plugged in for this y double prime minus y equals 0. And you did this. Okay. So this is y double prime minus y is equal to 0. And then you re-indexed. Is that what you're doing? You're trying to get these... Yeah, because what he's trying to do here is he's trying to get these to start, I think, at the same indice. So you said, okay, let k... Or here, let k equal n minus 2. So n equals k plus 2 for this one. So yeah, you're just re-indexing. So if n equals k plus 2, right, then this starts at 0. And then n is now k plus 2, k plus 1, a k, sub k plus 2. Okay. But now you can rewrite this. Yeah, no. Once you have this, now you can just say let k equal a, or no, let k equal, I don't know, z, and let n equal z on this one, right? Nice. So now you have the sum from z equals 0 to infinity. Wow, thanks for the follow, dude. Chicken.
I think the alert box is down. You got a subscription as well.
Yeah, I saw that. That was really nice, dude. Thank you. Yeah, okay, so now this is just z plus 2, z plus 1, a to the z plus 2, x to the z, minus the sum from z equals 0 to infinity, a sub z, x to the z. So now these are the same, right? These are starting at the same index, so I can write them in a single series. To infinity. And now it's z plus 1, z plus 2, a sub z plus 2, x to the z. Oh, wait. Minus a z, and then this is all times x to the z. Is that kind of what this is? Oh, it's a mess.
Matthew asks, can you explain the sigma notation?
Sure. Yeah. Okay. If I have sigma n equals 0, and let's say like to 5 of like x to the n, This is your starting thing. So this is x to the 0. And then sigma means you add the next term, where the next term is increasing this by 1. So instead of being x to the 0, now it's x to the 1 plus x to the 2 plus x to the 3 plus x to the 4 plus x to the 5. So this is for n equals 0. This is for n equals 1. This is n equals 2. N equals 3. N equals 4. It's you do this a lot in computer science. This is kind of like a loop. That's what this is. It's like a for loop where you're just like adding things, Matt. So where this gets a little bit more confusing, Matthew, and I'd have to know like how much calculus you know. Then we would just solve for az plus 2 by removing the summation. Well, one sec, and then this all has to equal 0 though, right? Oh. Actually, I think I know what you're talking about. Wait. Sorry. This is all equal to 0, right? Which means you could just like move this over here, right? And then yes, you could just get rid of the summations. So then you just have... You've done some basic differentiation? Yeah, cool. Okay. Yeah, so actually I think I see what happens here. So I can move this over to the right side. Keep this on the left. Okay. And now there's summations starting at the same z and ending at the same endpoint. Right? You understood that? Cool. Okay. And then I believe I can also divide by the x to the z, right? Because we have x to the z on both cases, yeah? Okay, cool. So let's get rid of that too. Nice. This goes away. This goes away. So then I have az plus 2 is equal to 1 over z plus 1, z plus 2, az, right? Okay. Which I feel like we need to use... I feel like we need to use this to figure out some more stuff. Oh, no. Okay. So if y of 0 is equal to 1, then that means the sum from n equals 0 to infinity of a sub n, and then this is x, right? This is going to be 0, right? 0 to the n, and we say it's equal to 1. So cool. So if you were to write this out, right, this would be a0, 0 to the 0, plus a1, 0 to 1, plus a2, 0 to the 2. These are going to go away, Dennis, right? 0 to the 1, 0 to the 2 is still 0. But 0 to the 0 is something very interesting, which is it's equal to 1. 0 to the 0 is equal to 1. So this now tells me that a sub 0 is equal to 1. Okay. How does that help me out there?
Which class in what way?
Could you help me with explaining some of the fractional negative indice rules? Yeah, totally, Matt. Yeah, actually, I've done videos on these. Let me give you the link for them real quick, just so while I'm doing this one with Dennis, you can maybe just take a look at it.
And then noise123 says which class? What do you mean?
Noise? Like noise?
No, noise123.
Oh, wait, what is he in? What chat is he in? Sorry.
YouTube.
Oh, YouTube. Why am I not seeing that chat come up? Oh, I do see it. I see it now. Okay. I believe this is a vector. I think this is Calc 3 for him is what it is. Rational.
Not even trying the boss. What's up, man?
What's up, dude?
Ceiling.
Dude, I swear I did this one. I did exponents. Oh, simplifying radicals. Yeah.
And whilst we love those hearts, could you please press the like button? We need the people.
We do like the lights. Yeah, keep going. Here we go. This is the video.
See exponents that are fractal.
I think this is the one, Matthew, you want to see. This is the video about doing things with weird rational exponents. So here, I'm gonna send this to you. Yeah, just take a look at this video. We're doing good, dude. Thanks, boss. But yeah, check that out. And if you have a specific question, I can go through it. But here, let's try to figure this one out for. Okay.
Yep.
So, yeah, what's up?
I was just saying, questions can be posted at naturaldiscord.com/submit.
That is
As
true.
It's written on the screen, so don't forget.
It is written there. Yeah, you can also do it there. Why do they tell me that the first derivative is also equal to 1? What does that really help me with? Oh, wait. If this one's equal to 1, guys, right? Then when this is 0, right? Then that tells me that a sub 1 is also equal to 1, right? Here, so this one, right? This tells me that a sub 0 is equal to 1. This tells me that a sub 1 is equal to 1, right? Okay. So, a0 equals 1. a1 equals 1. So, a2, which would be that one's equal to 1 over 0 plus 1, 0 plus 2, a0. So that's equal to 1/2. Wow, what's up, Pen? Thanks, dude. Appreciate you. Good to see you again, dude. Yeah, I caught your y'all's. Was that your last course you were doing with Zach? I caught that as I was like prepping for my lecture. I was like, oh, Penn Center's online. We'll go see a stream while I prepare to do how to figure out apparent weight in an elevator for physics.
Oh,
Okay.
More stuff from Noise. Can you explain Cartesian plan related to trigonometry?
Yeah, the Cartesian plane. Yeah.
What did I say? Cartesian plan, yeah.
Chicken Slicken. That's a great name. Chicken Slicken.
It is indeed.
17, the best prime number. So Penn Center says that on a lot of his math tests and stuff, he likes to pick the number 17 as the answer. So students know if they get the answer 17 on their test, then they must be doing the right thing. I think it's hilarious. Okay, so here's my question though. Like, bro, what are we supposed to say y is equal to? So I'm so confused here. Does something come from this? We've gotten to here.
Andy's way.
Okay, bye noise. Oh, it's related to some other series. Oh, okay. Well, I could like re-index this one maybe, but then that would be like z minus 2. Yeah, does this look like some series that we know? Like, am I supposed to integrate this? Because, okay, now we know, right? oh, that AZ is equal to Z plus 1, Z plus 2, AZ plus 2. So we have the sum from n equals 0 to infinity of Z plus 1, Z plus 2. And I guess there's an x to the n in there as well. Yeah, x to the n. Or not z anymore, sorry, because now we're doing with n. So n plus 1, n plus 2, x to the n. And then it's a n plus 2, maybe? I don't know, that to me is like kind of weird. I think it was x to the factorial, x to the something factorial with n.
If you just compute out the terms of a sub n, you get 1. A sub 0 is 1. A sub 1 is 1.
Correct.
A sub 2 is 1/2.
Yes.
A sub 3 is 1/6. A sub 4 is.
Oh, so you're saying?
24.
Oh, I just start noticing a pattern. Is that what you're saying here?
Yeah, pattern.
Thank you, P1.
That's what some of these are.
Oh, okay. Yeah, so we got this from the initial conditions, right? And then we got this, and then a sub 3 is the same thing as. I see.
If you had infinite time, you could compute it all.
Yeah, if
but no one has infinite time, so we have to.
So we start noticing it's a factorial. We start noticing it's a factorial.
Finite sequence, and then notice the pattern, and then try to prove the pattern.
I see. Okay. I see. So this is the same thing as a sub 1 plus 2, which is the same thing as 1 over 1 plus 1, 1 plus 2, a sub 1.
Yeah,
so,
and you know a sub 1.
And I do know a sub 1. You're right, that is 1. So this is equal to, yeah, 1/6. Wow. Okay, so then this is equal to 1/2, and it's 1/6. Is the next one like even cooler? I don't know. So that's 1 over 2 plus 1 over 2 plus 2. So that's 3.
A sub 2.
And then a sub 2, which is 1/2. So that's 1/3, 1/4, 1/12. So that's equal to 1/24th, right? Yeah? Okay.
Do notice the pattern yet?
Okay, so have we noticed a pattern yet? Maybe something with
denominators.
Yeah, 2, 6, 24. So that this is by a factor of 3. This is by a factor of 4.
Or 4. The next one's gonna be by a factor of 5.
Of 5, right? Yeah. Okay.
Yeah. Do you want to compute it and see if it is a factor of 5?
You know, I kind of do. You know, I really do. Just to make sure I'm okay, right? Let's do it.
Yeah.
3 plus 1, 3 plus 2, and then and then also but times 1/12, right? No, times 1/6.
What?
Because it's the 2 before it. Yeah.
Yeah.
Okay, so that's 5/30. So then this is 1 over 120, which, wow, that is a factor of 5.
My man.
Okay,
Wow.
cool. So it's like multiplying by 5, then it's multiplying by 4. So this is like, I want to say like n factorial.
Yeah, exactly.
Oh, is it actually? 5 times 4 times 3 times 2 times 1? What's that, 20? 6. Oh, it is. Oh, it literally is. Oh, that's so silly. Oh, so a sub n just equals 1 over n factorial?
Do you know what series you get if you put these as the coefficients?
Is it e to the x? Is it e to the x?
Yes, it is e to the x.
Wow. Okay, so then this is the sum from n equals 0 to infinity, and then it's 1 over n factorial x to the n, which, yeah, you're so right. I'm pretty sure this is e to the n. Infinite series chart. Where's my infinite series chart? Oh, it's buffering a lot on your end?
These
Oh, no.
Is it?
He says
I was
on
going to answer somebody's question. When and how often are these live?
Oh, good. Tell him. Give him the calendar. Give him the calendar. Tell him it's 3 times a week. It's calendar.actual.education, I think. Infinite series. Well, that's no. Series. You know, like e to the x, sine x. I don't know. I'm just like typing things. Can I just like have them? Here we go. This is what I wanted. Can they just give me the nice ones to it? There we go. Oh, but it's blurry now. And that's a Taylor series. We actually don't want that, do we? Well, that is kind of like an infinite series, though. Okay, whatever. I'm gonna take this.
You can also just check that e to the x satisfies the initial conditions and satisfies the differential equation.
You know, that's so right. Yeah. So here you go. This is e to the x. And then literally, yeah, the much easier way to do this, you're so right, P, right? Is just to recognize this as a homogeneous whatever, where you just say like, cool, y equals e to the x. Well, okay, if y equals, it's e to the ax is what it is, right? So y prime is equal to a e to the ax, and then y double prime is equal to a squared e to the ax. And so if you plug that in, you get a squared e to the ax minus e to the ax equals 0. You can pull that out. A squared minus 1 equals 0. A is equal to plus or minus 1 then, right? Yeah. So wait, so does e to the x and e to the minus x also work?
E to the minus x also works, but it doesn't satisfy the initial conditions.
Oh, interesting. Yes, you're right. The derivative has to be positive 1.
Minus 1.
Got you.
So if you
if
you basically drop the initial conditions and just look at the differential equation,
right? If we're just
doing
this
whole family of solutions,
yeah,
which is basically a linear combination of e to the x, e to the minus x, and a constant function.
Got you.
No, not a constant function.
Yeah, no, we didn't integrate or anything yet.
Yeah, not a constant function. So you get, if you don't look at the initial conditions, the solutions you get are linear combinations of e to the x and e to the minus x.
Which is then sine and cosine, right?
You don't get sine and cosine.
Oh, no, sorry. That's if they're imaginary. That's if a is imaginary. If this was a squared plus 1 was equal to 0, then you get sine and cosine. Yeah.
Then you get sine and cosine. Then you get the periodic ones.
Yeah.
But this one, because it doesn't have the sign flip.
Now wait.
You get the growth ones.
Oh, okay. I think I'm seeing it. Right, yeah. This condition here specifically, y prime is 1. That's the one that gets rid of the minus x, because this would be negative 1, and then this would be 1, but that's not equal to positive 1. Okay. So this is the one this is the one that gets rid of the e to the minus x.
Having these equations, it's so it's like if you imagine there's a space of solutions, having these equations like takes a slice out of your space.
Mm-hmm.
And so the space of solutions is 2-dimensional, and since you have 2 equations, that takes a minus 2 dimensions out of it.
Okay.
And you get one solution.
I see. Yeah. It's like the degrees of freedom go away.
Yeah.
Nice.
If you only have...
That's a cool question. Go on.
If you only have one equation, you get a 1-dimensional space of solutions, and if you have 2 equations, you get a 0-dimensional space of solutions.
Very interesting. Or then you could have infinite number of solutions, I guess. Wait, why is my points thing not working? What the hell? Okay, whatever. Add amount 1 Dennis.
Alright, I think I gotta go now.
Oh, thanks for being here, P127. I appreciate you are very smart for being 16. just know that, please. You are very smart for being a 16-year-old.
Okay, sure.
Yeah.
Alright.
Believe it. Alright, let's have it. Todd? Todd's got a question? Todd, my boy. And then we got a couple web ones. Oh, this is from Matthew. What's up, Matt? Okay, cool. Alright. the area of a rectangle is 142 centimeters squared. It has a length of that. Calculate the width. Give your answer in the form A times B plus C square root of D. Okay, cool. All right. So, Matthew, let's remember. Area is equal to length times width. Okay. And we were told that the length is equal to 2 plus 5 root 3. And then we were told that the area was also equal to 142. Okay. So, what I can do is I can plug this in for length. So then I have 2 plus 5 root 3 in parentheses times the width is equal to 142. Okay? The next thing to do, this is kind of like algebra, right? Anytime I have like something attached to a variable, I can just divide by that thing to get it off, right? And this is probably where you're a little bit confused, because you end up getting that W is equal to 142 over 2 plus 5 root 3. This is not proper, because you don't really want to have radicals and stuff down here in the bottom. Okay? So, what we do here, in order to get rid of this, in order to rationalize the denominator, is we're going to multiply by the conjugate, which the conjugate is the same thing that this is, but instead of plus, we put minus. So this is 2 minus 5 root 3. And then this is 2 minus 5 root 3. Okay? When we do this, this is gonna multiply inside for each one. So that's gonna end up giving me 284 minus, I need to do the 5 times 142, so that's 710 root 3. Yeah, 284, 500, 700, 710, okay. Over, and then this is a situation where you have, if you have A plus B times A minus B, this is A squared minus B squared. So this is going to be this thing, which is A squared, so 2 squared, and then minus 5 root 3, all of that squared. Okay. So this is going to equal 284 minus 710 root 3, and then it's over 2 squared, which is 4, minus, and then this comes in for the squaring, is going to be minus 25 times 3. So now we have, this is 284 minus 710 root 3, all over 4 minus 75, which is negative 71. Oh, very cool. Watch what happens here. So this over this is negative 4. 4 times 70 is 280, so 4 times 71 is 284. But then there's a minus sign. And then this, so 710 over 71, right? That's just a factor of 10, right? Because 71 times 10 gets me 710. So this is going to be negative 4 plus 10 root 3. And that should be your final answer. So, yeah, and this... they said give your answer in the form A plus B, A times B plus C squared of D. Oh, interesting. Okay. Okay. So here's where A must be greater than 1. Okay. So negative 4 plus 10 root 3. So this would be negative 4 plus 10 root 3. But then they want me to pull something out. And the biggest thing I can pull out of all these is 2. And it has to be A has to be positive. So this is 2, and then this is negative 2 plus 5 root 3. That would be your final answer. I'm pretty sure. Does that help you out, Matthew? Kind of weird that they have them put it in that form, you know? Is this GCSE? Sensation? Is this GCSE? Oh.
I got caught stretching. Yeah, it looks like it.
Yeah, this looks like a GCSE question, I think.
Yeah, looks like definitely higher.
Yeah, I mean, so this concept is like not too hard, but what was kind of annoying was having to do the multiplying by the conjugate and then to get it specifically in this form. It's just ugly. Luckily, everything cancels out, which is nice. Oh, Todd was typing something. Let's see what Todd says. He was in the chat. Or he was typing.
There's an extra course called Added Maths between GCSE and A-Level.
Oh, that's what he says? It's called Added
But
Maths.
I would have said that's higher GCSE. Because I think I answered a question like that.
Oh, it helped confirm my answer. It's an extra course. Oh, okay, very cool. I see. Oh, my chat just wasn't even loading. That's why I didn't see anybody's chat earlier. Okay, nice. Okay. That's cool. Yeah, how rude indeed. This is one of the easier questions, but on paper they do get harder. That's okay. I mean, please feel free to, to bring them on. We have these streams, 3 times a week and stuff. So if you have other questions on stuff, please bring them by. We'll help you out with them. Also, you get a coin for like answering a question. So here, congratulations. Yeah, you're very welcome. Yep, all good. You have to go.
Well done.
Okay. I think that's all the questions we had for today, right? Do we have any other ones, Sensation?
There was that one in office hours, but Todd's going, so I know you did that one.
No, I think you got all of it. Yeah. Was there one? I mean, we did question one of Dennis's. The other ones I probably could figure out. Matthew posted a lot of times. They just spam that submit button, it seems like. Like 5 times. That or my code is messing up, but I think they're just hitting submit a bunch of times.
Yeah.
Wait, you know what I want to do? I want to do this one just for fun, and then I'm going to call it. But let's do the soccer mom, the 100 IQ soccer mom questions.
Oh,
These are so fun. These are so much fun.
100.
Yeah, 100 IQ. Yeah, 100 is actually not that big, right? For IQ?
No, it's the dead average.
Average is scary, dude. They say, what is it? I always love this quote, 50% of the population is below average.
Christ.
But like, average is scary. Okay, let's do some soccer mom math, dude. I love this. Okay, 3 beers is equal to 30. A beer and 2 cheeseburgers is equal to 10. A cheeseburger and 4 beers is equal to 9. What is this integral?
Wait, so the beer is worth 10, the burger's worth...
I wonder if someone's trolling me
5?
here, dude. I don't think I've ever seen one with integrals on it, dude. What? Also, where did the hot dogs come from?
Yeah, I think that's just messing with you at that point.
Now let's check it out. I think we can do it. Okay. Okay. So I'm gonna call these things X. Sec. I'll call these X. So X must be equal to 10. What's up, Frisian? So then this is, let's call this thing Y. So X plus 2Y is equal to 20. So that means Y must be equal to 5. All right, then let's get the beers. So this is Y, and then we're going to call this Z. So Y plus 2Z must be equal to 9. So Z must be equal to 2. Right?
Yeah.
Yeah. Okay, cool. All right, so now we're taking the integral of 2 cheeseburgers. So 5 plus 5, which is 10. 10 minus x. 10 minus 10 is 0. Okay, so 0 to infinity. Oh, I like this. This is okay. Soda beer, which is 10 sine hot dog. We're going to call this h. Over 2h dh. Ooh, this is a fun one. Okay. So 10 over 2 is the same thing as 5. So we have 5 integral from 0 to infinity of sine of h over h dh. This is an identity, I think, is it not? Sine, I know the limit as h approaches 0 of sine of h over h. I believe that's equal to 1. Is that the one I'm thinking of? Oh, limit as x approaches 0 is equal to 1. Yeah, okay, so I have that one right. Yeah. Yeah. This is kind of like a... These are important. Okay. What is this though? What's the integral of sine of h over h? Do I have to do integration by parts? I feel like I do. Unless this is I'm pretty sure this is an integration by parts. Okay, so we have u dv du and v. So I'm going to call dv equal to 1 over h. So integrating that should just give me ln of h. U I'm going to say is sine h. So du is cosine h dh. Okay, this is 1 over h dh. Okay. So now this is 5. So it's uv. So sine of h, ln of h from 0 to infinity. Minus the integral of v du. This is even worse. Oh. ln of h, cosine of h. Oh, this is not good. Oh, we don't want to do this. Man, I thought I could get rid of this somehow. Oh, yeah, the problem is that like integrating h up doesn't help you. I can see it. Yeah, I can see it. ln of h. Okay, what? How do you do this?
Just drop it to ChatGPT and hope for the best.
Oh, it's a Laplace transform? Wow. Apparently it's pi over 2. I don't think this is a very straightforward proof. Or there's a Feynman's trick. Wow. I don't know how they're doing this. Anyways, it's pi over 2. I guess you could do a Laplace transform for this as well. But man, that seems very involved. This is very very involved for soccer mom. Soccer mom's not gonna be doing Laplace transforms, even if she has 100 IQ.
What about chess moms?
Chess moms? Chess moms probably do it. Yeah, chess moms probably do it, because this is apparently the whole process you have to do. Yeah, I don't want to have to do a Laplace transform.
Can't even read that.
Yeah, this is called Laplace transformations.
Is that a bee or a thorn? You know what I thought it's right.
What are you talking about?
It looks like I can't even tell if that's a bee or a thorn. Look there, pi over 2 minus tangent to the -1.
Oh,
is that a bee or a thorn?
Or a thorn?
A thorn.
What's a thorn? Like a rose thorn?
No, like Old English th sound looks like that.
Oh, I didn't know that one. This is something. Something like this. This is a thing in English.
Seriously, just Google thorn letter.
Oh, I'm going to.
It's a eth sound.
Oh.
There.
Oh, it's like Swedish. Oh, that's so cool.
Old English.
Oh, I didn't know this. What? I learned something every day. Thorn. Yeah, okay. But anyways,
So,
this is a little Laplace transform.
ETH.
So this is equal to 5 pi over 2. Congratulations. You are now level 100 IQ soccer mom.
So much hassle.
That's so funny, dude. They really did troll at the end here. This is such a troll.
Well done.
Okay. I think it's all the questions we have for today. So maybe let's end the stream out, yeah? We did it,
Okay,
yeah?
okay.
Yes. All right, cool. Thank you, everyone, for coming office hours today. Really appreciate all the questions and stuff. Thanks for staying patient with us while Sensation helped me figure out what was wrong with the stream. I think we're good now. Yeah, I think you were right, Sensation. Even though I am like mad at my bandwidth, I think there was a serious issue with just OBS. So I'm gonna try this, just piping it directly through something else until I rebuild OBS. But that's gonna suck. I'm really dreading doing that. But you're right, Sensation.
I'll tell you something after stream. But yeah.
Okay, cool. All right, cool. Okay. That being said, our next stream is going to be... Or actually, I don't know if I can stream tomorrow. Oh, yeah, wait a minute. 10 to 12, 2 to 4. Yeah, tomorrow's stream will probably be delayed as well, because I have to substitute in for a professor who's in Paris. I have to substitute in for his class, and I think his class is 2 to 4. And we usually stream at 4 o'clock, so it'll maybe be an hour later tomorrow. So that would be 5 p.m. Pacific, 6 p.m. Mountain, 7 p.m. Central, whatever, 8 p.m. Eastern. Yeah, okay. All right, let's go raid somebody. See what's going on. Monday chat with mother. I don't know about that. Repurposing my old. Let's see. Let's go say hi to High Potential. It looks like he's doing something cool. He's like making a video or something. I don't know. All right, cool. All right. That being said, enjoy the rest of your Monday. Great start to the week. We'll see you guys tomorrow. Peace. End that, and then let me end this one as well.